Okay, two blocks of different masses are released from identical springs of elastic constant K equal to 100 Newton per meter. Okay, there are two blocks, which means masses should be different. See, block X has a mass of 1 kg, M1 is given, M2 is given over here. Okay, released from the identical springs, which means what? So K1 should be equal to K2 with elastic spring constant, which is equal to 100. This is also given to you. Okay, what are the velocities of the block when they leave the springs? So what do we infer here? See, why should the blocks move from the spring? It is like this. See, there is a spring connected like this. There is an object kept over here. Okay, so the moment you compress it and leave it, the object automatically moves like this. Why should it move? Because this gives you some energy. What is the energy here? The energy stored in the spring is nothing but half kx square. And what is the energy it receives? It receives an energy equal to half mv square. So these two should be equal. Let us equate that. First, what we need the velocity of block x. So therefore, let us substitute. I'll write half into k is already 100 delta x extension, which is what is the extension here? Extension given 0.01 x square is equal to half into what is the m here? M1 is 1 kg multiplied by v. Is the value of v1 given? No. So it is vx square. Okay, so therefore 100 into 0.01 goes away, it becomes 1 over here. This half and this half cancels over here. So vx should be equal to 1 square, or vx should be equal to 1 over here. So vx equal to 1. So therefore definitely this and this is incorrect, right? Now we need to find out the value of vy. How do I find the value of vy? So once again use the same formula. So therefore this should be half into 100 into 0.01 should be equal to half multiplied by, what is the mass of the second one? Second one mass is 0.25 into vy square. I do not know what is this value. So therefore now vy square will now be, so this goes away, this goes away, this goes away. So vy square is equal to this 0.25 goes that side, so it becomes 4 over here. So vy should be equal to 2. Okay, so the answer is 1 and 2. 1 and 2, which one is it? 1 and 1 here. No, this is incorrect. 1 and 2 is correct. So C is the right answer. Okay, so there have been some responses to this video earlier I had posted, and the question that people had asked here is that why are you using conservation of energy over here? I use conservation of energy. Why not conservation of momentum over here? The reason why I do not use a conservation of momentum is that when I have a spring and I have a mass attached to it, what do you mean by conservation of momentum? Okay, so conservation of momentum, what is the momentum of this spring? See first of all, what is the momentum of the system? Momentum of system is equal to 0 initially. What is the momentum of this spring? This should be kx divided by m. What is kx? Force divided by, this is only force you are getting. So when you get force, this should be force divided by time. I should get kx divided by time. If I get the momentum of this one, and similarly I can find this one, which is m into vx. Okay, so if I want to get this value, I should get the time. Is the time given to me? Time value is not given to me. So therefore it is not possible for me to determine this. Okay, so I am not using conservation of momentum here, but of course momentum is being conserved over here. You can use it, but until and unless time is not given, you will not be able to do this. Okay, let us move on to the next question.